Hi students, welcome to the part 1 of the different types of chemical reactions. Here in this video we will discuss about the different types of chemical reactions. First let's study about the combination reaction or a synthesis reaction. What a synthesis reaction is. So when two or more elements or substances combine together to form a new substance, the chemical reaction is called as a synthesis reaction or a combination reaction. So in simple words, when two substances combine and form one substance, that is a combination. Here is one example: magnesium reacts with oxygen, and now two substances combine and they form one substance, that is magnesium oxide. So this is a combination reaction because two things combine and form one substance, that is magnesium oxide. I have performed this experiment. I want you guys to have a look at this, how the magnesium reacts with the oxygen. How does it burn? How the magnesium burns, right? So let's have a look at this video. See guys, this is the magnesium strip I'm taking here, and it starts burning with a dazzling flame. You can see how the magnesium strip burns. Okay, and interestingly, the kind of an ashes that you will see there, very interesting, right? The magnesium oxide, this is the magnesium oxide. Okay, this white color, right? This is the white color magnesium oxide. You can see here, these are simply the ashes, right? The magnesium oxide. Here the magnesium reacts with oxygen and forms the magnesium oxide. So this is what? This is a combination. If you want to look at this video again, you can just see it right here, right? Just see it. Just see how the magnesium burns. Okay. Okay, so this is what here now. This is the magnesium oxide. Okay. So you are left with the magnesium oxide. So again, this is a combination reaction. So magnesium reacts with oxygen, but this reaction normally it needs a heat, right, initially to take place. So that's why I'm burning it, giving it an ignition temperature, and once it gets ignition temperature, it forms the magnesium oxide. The other reactions are carbon can react with the oxygen and forms combination, carbon dioxide. Again, another combination reaction, isn't it? This is one more combination reaction where two elements combine and form one substance. Okay. So another one, hydrogen and the chlorine, again they combine and form one substance, HCl. Right, two elements combine and form one substance. Another one, ammonia, it reacts with the hydrochloric acid and forms ammonium chloride. Right. So in these reactions, what we find, in all these reactions we find two substances combine and it forms one new substance. So in a combination reaction, two or more substances combine and form one new substance. Let's have a look at another reaction, decomposition reaction. Now decomposition, a reaction in which a substance is decomposed, is broken down, right, into two or more simpler substances. That's a decomposition reaction. Okay, so one common example is silver chloride. See, the silver chloride is actually a white, it has a white precipitation, white color, right? Okay, it's a white color compound, silver chloride, and once you expose it into the sunlight, it forms the silver and the chlorine. Here the silver chloride, one substance breaks down into two new substances, silver and chlorine, in presence of sunlight. Okay, so this is what? This is a decomposition reaction. So silver chloride in presence of sunlight breaks down into two simpler substances. Here again I have prepared a video of this silver chloride getting decomposed into the silver and chlorine. Let's have a look at this video. You can see this is the silver chloride HCl that I have prepared in the lab. And quickly after preparing the silver chloride in the lab, I take it on the filter paper, and you can see initially it is white precipitation, but once I go outside my lab with this filter paper, quickly within no time it changes its color. Now it's a gray color, right? Isn't it? So why? Because silver chloride on exposure to the sunlight, it gets decomposed. It forms the silver and the chlorine. So this is what you get, the silver here. Okay, silver chloride breaks down into silver and the chlorine gas that goes into atmosphere here. So here this is a one simple example of a decomposition reaction. Okay, so silver chloride in presence of sunlight, okay, silver chloride in presence of sunlight breaks down into silver and the chlorine. There are many other examples of decomposition reactions. Suppose you take the calcium carbonate, the limestone, right? You heat it strongly at a very high temperature, so you get calcium oxide, quicklime, and the carbon dioxide gas is formed. So one substance breaks down into two substances here. Okay, so this is again a decomposition reaction. Another decomposition reaction, let's have a look at this one. Ferrous sulphate. Once you heat it, you get the ferric oxide and sulfur dioxide and sulfur trioxide. So one substance, ferrous sulphate, breaks down into three new substances. So this is what? A decomposition reaction. Okay, another reaction, silver bromide, similar to the silver chloride, on exposure to the sunlight again breaks down into silver and the bromine. So you get the metallic silver here, right, and the bromine. So again this is a decomposition reaction. Now let's discuss about the displacement reaction. Those reactions in which one element takes the place of another element in a compound is known as displacement reaction. Okay, suppose here we have a zinc, metallic zinc. It reacts with a copper sulfate, aqueous solution of copper sulfate. Zinc can displace the copper from the copper sulfate solution and forms the zinc sulfate, and you get the metallic copper. Okay, so here zinc can take the position of copper. So one element takes the position of another element in a compound. That's the displacement reaction. Here the zinc displaces the copper from the solution. Okay, so why? Because zinc is more reactive than copper. So in a displacement reaction, always a more reactive metal, more reactive element can displace a lesser reactive element, which means here zinc is more reactive than copper. That's why the zinc can displace the copper. The reaction cannot go in the backward direction, means copper cannot displace the zinc from its solution. Why? Because copper is not more reactive than zinc. So a displacement reaction is possible only when a more reactive metal displaces a lesser reactive metal. So let's again have a look at this video I have prepared here, right, for the displacement reaction. So you can just watch this reaction. I'm taking the copper sulfate in the distilled water. Okay, so prepare a copper sulfate solution. Copper sulfate solution initially is blue. Okay, and once I shake it, you prepare a copper sulfate solution, and after that add here the zinc metal. So this is the metallic zinc. You add it in it, right? Just wait for 1 minute. Okay, just waiting for 1 minute. After 1 minute you will find some precipitation of the copper, okay, in this reaction mixture. You shake it, you can see here, right? Upon shaking you can just see the flakes of this copper, right? Okay, the precipitation of the copper. You can see this, the copper is being, actually precipitated out. So why? Because zinc metal, the metallic zinc, takes the position of the copper, so it displaces the copper from the solution. So let's have a look what actually happens here. For example, if I take here the zinc, if I take here the copper sulfate solution, and in this copper sulfate solution let's add the metallic zinc. Okay, once I insert the zinc rod in it, so what I find, just after some time, right, if you wait for some time, you'll find that there is a kind of a precipitation that is formed here, and the metallic zinc rod, it will start dissolving in it. Its weight will decrease. So you get here the copper, metallic copper, precipitation of the copper, right, after some time. Why? Because zinc displaces the copper from the solution. So actually you had the copper ions from the solution, and that copper ion actually precipitates out. It accepts 2 electrons and forms the solid copper, right? Copper 2 positive ion accept the 2 electrons which actually are lost by the zinc and forms the copper, solid copper. Now the zinc, the metallic zinc, is changed into zinc ions, right? Zinc 2 plus and 2 electrons. These 2 electrons are actually accepted by the copper from the solution, and it forms the metallic solid, metallic copper here, the precipitation of a copper. So which means that zinc, being more reactive metal, can displace the lesser reactive metal like the copper. Not only the zinc, we can use other metals to displace the copper, right? So we can use the iron also to displace the copper, which means that copper is less reactive than zinc, so than the iron. Okay, so you can use the iron metal, iron nails, suppose. Okay, you can take iron nails in the copper sulphate. Again, you will find there also the copper being precipitated out, which means that iron is more reactive than copper. We can also use the lead to displace the copper, right, and form the lead chloride and the copper. So in all these experiments, what we find that these 3 metals, zinc, iron, lead, they can displace the copper, which means that all the 3 metals are more reactive than copper. So copper is less reactive than any of these metals, right? Let's have one more look at another displacement reaction. Now this is the reaction between the zinc and the dilute H2SO4, the sulfuric acid. From the sulfuric acid, you can displace the hydrogen by the zinc, and what we get the zinc sulfate plus hydrogen gas. It means that if I take the dilute H2SO4 solution and then add some metallic zinc, I should get the zinc sulfate and the hydrogen gas. Okay, see, this is the dilute H2SO4. I am going to react this dilute H2SO4 with the metallic zinc. Okay, then let's see what happens. This is the dilute H2SO4 in a conical flask, and now I am going to add metallic zinc, right? This is the zinc metal, and now we can wait for some time and observe the reaction. Okay, we can wait for a couple of minutes here and observe the reaction. You'll see the bubbles of the gas will start, right? You'll see here, over here at the bottom, right? You can see some gas bubbles start, right, forming. Okay, so this is what? This is the hydrogen gas. You can see the bubbles coming out. This is the gas, hydrogen gas actually. This is H2 gas, which is formed from the sulfuric acid. Why? Because zinc is more reactive metal. It can displace the hydrogen from sulfuric acid and form the zinc sulfate and the hydrogen gas. So this is again a displacement reaction. Hope you got the concept. Thanks for watching the video. Bye for now.